Hi everyone, welcome back to our YouTube channel Electro Study. This is lecture series 18 Computer Networks dealing with classless addressing. Come, let's go into the video. Please do like, share, subscribe and comment. In last video, we have seen about classful addressing. So we said there was a disadvantages and why we isolated classful addressing. So even though there are many disadvantages, there is one advantages in classful addressing. That is, if you find the class of the address, then you can fix the prefix of that address, and you can extract the address which is belonging to which class. So this was the advantages. After seeing the advantages and disadvantages, we moved into classless addressing. So in classless addressing, what happened is there were more number of spaces to store the data, but such space is not actually needed. So here in classless addressing, the internet providers thought about a different aspect that came into existence. So how this classless addressing came into existence? So during 1990s, what happened is there was a provider called as Internet Service Provider. They were into existence. So what these internet providers did is it was having an organization where there was no need of providing a big internet controlling big network. It was like very internet access was provided for very small individuals, small businesses, mid-size organization. So it was easy for the service providers to provide the services to the organization. But then that did not satisfy the work or the network coverage what we had. So in late 1996, what happened is the internet authorities announced a new way of architecture. That new way is nothing but it is classless addressing. So in classless addressing, what happened is the address spaces were divided into variable length blocks. See, address space will be divided into n number of blocks, but all these blocks does not belong to any classes which we saw in classful addressing. It was just divided into variable length, and the prefix of the length, that is the prefix and suffix part of the block in classless addressing, is the prefix length in the class addressing is a variable part, whereas in class full addressing it was fixed. So it was easy to see the address where in which class it was associated. But here the prefix of the block, that prefix length of the block, is variable, and size of the network is said to be inversely proportional to the length of the prefix. So what you can understand from this, if suppose the length of the prefix is lesser, then the size of the network will be larger, and goes the vice versa. Next is, for representing this prefix length, there is a format. We tell that format as slash notation. So what is slash notation? Here, see, since the prefix length is not inherent in address, we need to separately give the length of the prefix. In this case, the prefix length n or m, whatever we specify here, this prefix length is added to the address separated by a slash. All the addresses will be giving a byte with separated by a dot, and finally the prefix length here, it will be specified with a separated by a slash. So this notation is formally referred as the slash notation. You can otherwise call it as classless interdomain routing. You can either call it as slash notation or CIDR, that is classless interdomain routing. Got it? Now, how to extract information from an address? So there are some 3 steps that is followed. See here, your prefix is of variable length and you have a suffix, and your prefix is divided into the first address and the last address. Now there are steps to find which is the first address and which is the last address. So see here, the number of addresses in the in the block is found as n is equal to 20, 2 to the power of 32 minus n. See here, the capital N refers to the number of bytes that you can store. It refers to 2 to the power of 32 minus n. Then what happens is, to find the first address, we will be considering the leftmost bits. And you have to set all those leftmost bit to zeros. Got it? So if you want to find the last address, you will keep the value of n leftmost bit. You will choose the leftmost bit and you will provide ones to the all rightmost bit. Got it? This is how you will find the address. If you want to extract the first address, you will be adding zeros to all the rightmost bits. If you want to find the last address, you will be adding ones to all the rightmost bit. So here in this diagram, you can see that the prefix part will be same, and considering the last bit, that is rightmost bit, you are adding zeros. Here it is added as 1. This is how you can extract the data from the block. And there is a term called address mask. So this is nothing but it is the another way to find the first and the last address in the block. This address mask, it is 32-bit number in which the leftmost bit are set to 1. Here the leftmost bit will be set to 1 and rest of the bits will be set to 0. Be clear, when you're finding your first address or last address, you are taking the rightmost bits, adding zeros or ones. But here in address mask, what happens is, you are taking that 32-bit number and the leftmost bits are made 1 and the rest of the bits will be made 0. Now the computer can easily find the address mask by implementing the number 2 to the power of 32 minus 1. 2 to the power of 32 minus n minus 1. Got it? So the reason for defining a mask in this way is that it can be used by the computer program to extract information in the block. That is, it can use some bitwise operator like or, and, not, whatever it is. So here what happens is, the number of the address in the block, which we represent as n, will be given as not of address mask. That is, whatever you provide, you will be changing. If it is 101 means 010, like that you will do. Not mask plus 1, you will be adding 1 to the result. First address in the block, if you want to find, then it is any of the address in the block doing AND gate with the address mask data. So whatever you are getting in address mask, that will be and made and with the any of the address in the block. So same wise, last addresses, you will be taking any of the address in the block and putting OR operator to the not mask value, not the same mask value. It will use not mask value provided the OR gate between your any address in the block. So see here, this is the given address in the binary notation. Not is nothing but you are now providing all zeros and providing only the rightmost will be given by 1. Now these two will be made OR of 1 0 is 1, 0 0 is 0. So this will be your last address. If you want to find the first address, what happens is, this will be your given address. You will perform AND gate considering the rightmost values to be zeros, and doing AND gate will give you the first address of the network. Hope you're clear. Thank you. Stay tuned for more information.